Hello there, amazing people, all the students, lovers of chemistry out there. I'm excited to be here with you on yet another episode, precisely the third part of this series on naming organic compounds that we've been looking at thus far. And on today's episode, we want to look at the concept of classifying bonds. We want to talk about the alkanes, we want to talk about the alkenes, and we want to talk about the alkynes. So right before we get into what we have for today's video, I want you to do me a favor by telling me in the comment section what topic you'd like me to treat next. You see, I don't just want to go talking about stuff that you're not interested in. I want to talk about the things that are giving you a difficult time, okay? So I want you to do me a favor by letting me know in the comment section what topic you'd like me to work on next, and I'll be more than happy to make a series on that. So let's get into what we have for today's video. First off, let's start with the first group, which is called the alkanes. All right, so alkanes are organic compounds, all right, that have only single bonds between carbon atoms. Now, in the beginning of this series, we talked about organic compounds as compounds that contain carbon as their foundational structure. Now, carbon has the symbol, a capital letter C. Now, in a particular group of organic compounds that are known as hydrocarbons, they are the organic compounds that are made mostly of carbon and hydrogen. Now, alkanes are a group of organic compounds that contain carbon and hydrogen, and they have only single bonds between carbon atoms. Now, here is an example. We mentioned that carbon has the ability to form bonds between itself and between other atoms. So you can have one carbon atom forming a bond with another carbon atom, which forms a bond with another carbon atom, which forms a bond with another carbon atom, and so on and so forth. Now you can see I have labeled the bonds over here, and you can see in this case the bonds are single bonds. There are cases where carbon can form more than one bond. It can be a double bond, it can even be a triple bond. So in a case where the bond is just a single bond between two carbon atoms, or all the carbon atoms in the entire molecule, then we call it an alkane. So that's the concept of what alkanes are, and we want to be seeing how we can name them correctly. And by the way, alkanes are actually the simplest hydrocarbons that we have among our organic compounds. So here is a naming tip for identifying alkanes. The first thing you need to do is to use the base name. The base name is also known as the parent name, and we talked about that in one of the previous videos on this series. Okay, we talked about how that if it is just one carbon atom, you use the base name METH. If it is two, you use the base name ETH, and so on and so forth. So to name an alkane correctly, what you do is to use a base name that shows how many carbons are in the longest chain, and then you add the suffix ane, which is pronounced as "ane" to show that it is an alkane. Now we have this example here on the screen right now, and you can see the first step we are to take is to number the carbon atoms. So to do that, let's start from the left. We can start from the left, we can start from the right, whichever position we want, because we do not have any branch or any substituent. We'll be getting into cases where we have substituents. So let's start with this one first. So you can see, to count the carbon atoms, we have carbon number 1 over here, carbon number 2 over here, and carbon number 3 over here. So we have the total number of carbon atoms to be 3, and when we do that, we call it PRO, or we use the prefix or parent name PRO, which stands for pro. All right, so now that we have done that, the next thing to do is to identify if it is an alkane or not. Now you know that alkanes have only single bonds throughout their structure, and you can see in this case it is just single bonds that we are having throughout. So this qualifies to be an alkane, and since it is an alkane, we just simply add the suffix ane. So pro plus ane gives us propane. Okay, so here where I mentioned pro, I forgot to add one letter. It is actually PORP, not just POR. Prop. So we have propane. Propane is the name of this compound. So now that we have done that, let's move on to the next thing that we have on our list. I'm sure this has been educative for you. We've talked about alkanes. Now let's move on to the next class of hydrocarbons that we have, which is known as the alkenes. Now, in the case of alkanes, we mentioned that they have single bonds throughout their structure, but alkenes, on the other hand, have at least one double bond between carbon atoms. Remember, I said in organic compounds you can have multiple carbon atoms forming bonds between each other. Now, if it is an alkane, you have single bonds throughout. But when it comes to the concept of alkenes, you can have a double bond as it is identified over here. Now, when that happens, what do you do? Let's see some steps to naming alkenes. So here is a naming tip for you. To name an alkene, you are to use the base name and then add the number that shows where the double bond is located, and then you add the suffix ene, which is pronounced as in. Now here is a tip: start numbering from the end closer to the double bond. I'll show you an example right now. So for example, let's say we have 1 2 3 4 5 6 carbon atoms, and then we have some single bonds, and then we have a double bond over here. All right, so if we have hydrogen filling up the rest of this molecule, what we are going to do now is to see how these steps that I just talked about will apply to this molecule. So they said the first thing to do is to use the base name. So what is the base name or the parent name? Let's count the number of carbon atoms to identify that. 1 2 3 4 5 and 6. So we have 6 carbon atoms, and the base name for 6 is hex. Now that we have identified the base name, we are to identify the number where the double bond is, and the tip says start numbering from the end closer to the double bond. So we can start numbering from left to right, or we can number from right to left. If we number from left to right, this double bond over here will receive the number 3 because it is this carbon atoms that carries this double bond. But if we start numbering from right to left, what number will the double bond have? It will have 1 2 and 3 as well. All right, it will also have 3 as well. So we can number from either the left or the right. So the double bond is on carbon number 3. On carbon number 3. So we have hex plus 2ene. That shows that, sorry, not 2, 3ene. That shows that the double bond is on carbon number 3. And then we add ene, which we have done over here. So the complete name will now become hex 3ene. That is the complete name of this compound. So let's deal with one more example on this and then we'll proceed. All right, so on the screen right now we have an example of this compound or this molecule over here, and we have been asked to name it. So the first thing we need to do is to find out the parent name, the base name, by numbering the carbon atoms. So we have CH2 with a double bond, and then CH, and then CH3. How many carbon atoms do we have? We have 1 2 3. 3 carbon atoms gives us the name PROP, prop. The next thing we are to do is to identify the position of the double bond, and we are to identify it in such a way that it has the lowest number possible. So in this case, we counted from left to right. And when we counted from left to right, this double bond was placed on carbon number 1 because it is this carbon that owns this double bond. If we count from right to left, however, this will be number 1, number 2, and this will be number 3. this carbon atom will be the one that owns the double bond. So the double bond will be on carbon number 2. So counting from the left to right will be the correct way to count, because number 1 will be lower than number 2. So to identify the position of the double bond, we'll just simply say 1, and then we add the suffix, which is ene. So we have the complete name prop plus 1 plus ene. That gives us prop 1 in. We can also call this propene. So that's how we name compounds that have a double bond in their structure, or alkenes. Here is another example to solve. So let's do that very quickly. We have this molecule over here. So let's number the carbon atoms. Are we starting from left to right, or are we starting from right to left? Let's see. We have CH3, we have CH, and then we have CH. We have CH3 as well. Starting from the left, this will be number 1, number 2, number 3, and number 4. So we have 4 carbon atoms, which give us the name, or the parent name, but. So if we start from the left to the right, we observe that this carbon atom, the carbon atom number 2, is the one that owns this double bond. If we start from the right to the left, we'll also observe this is number 1, number 2 as well. So number 2 will own the double bond. So we can start from either the left or the right, whichever one we choose. So to identify the double bond, it is on carbon number 2. And then the suffix, or the last part of the name, is ene, which shows that it is an alkene. So adding them together now gives us but 2 in, showing us that it is an alkene and that the double bond is on carbon number 2. I'm sure this lesson has been super helpful and educative for you. If it is, please do me a favor by liking this video, subscribing, and turning on the notification bell icon, so when more videos like this come out, you'd be the first to be notified. Alright, now let's proceed to the next concept that we have, and we're talking about how to name compounds with triple bonds, that is the alkynes. Now we've talked about alkanes, we've talked about alkenes. Let's talk about the last category for today's video, which is alkynes. Alkynes have at least one triple bond between carbon atoms. Remember, we said in organic compounds, carbon can form bonds between itself and other elements. Now in a case like this, it can be a single bond, it can be a double bond as we have over here, and it can even be a triple bond as it has been identified over here. Now when we have the case of a triple bond being present, what do? The step says to identify the base name, use the base name or the parent name by counting the carbon atoms, and then number the triple bond and add the suffix yne. Yne is pronounced as "ine". Now remember to always number from the nearest end to the triple bond. Now we have this example over here: CH3, CH2, C, the triple bond, C, and then CH3. So let's do the first step. The first step says we need to identify the base name or the parent name. How do we do that? We number the carbon atoms. How many carbon atoms do we have? We have 1, 2, 3, 4, and 5. 5 carbon atoms gives the prefix PENT, pent, showing that there are 5 carbon atoms in the organic compound. The next thing to do is to identify the number upon which the triple bond is located. Now, are we going to count from the left to the right, or are we going to count from the right to the left? If we count from the left to the right, this triple bond is on carbon number 3. But if we count from the right to the left, this will be number 1. Number 2 will own the triple bond. So in this case, we're going to be counting from the right to the left. So doing that, we know that the triple bond is on carbon number 2. And then the final name is YNE. So altogether we have PENT plus 2 plus YNE. That gives us pentyne. That is the name of this compound, showing that it is an alkyne and that the triple bond is located on carbon number 2. I hope you're seeing how all the steps are being taken. Here is another example for your consumption. We have this molecule over here. So first things first, let's identify the parent name. We count the number of carbon atoms, 1, 2, and 3. So we have 3 carbon atoms, which gives us the name PROP. That's the parent name of this compound. Now, the next thing to do is to identify the position of the triple bond. And to do that, we need to know whether we're counting from the left to the right or from the right to the left. In this case, if we're counting from the left to the right, this triple bond is on carbon number 2. But if we're counting from the right to the left, this triple bond is on carbon number 1. So we're going to be counting from the right to the left in this case. And then the triple bond is on carbon number 1. The final name or the suffix, the final part of the name is YNE. So we have PROP plus 1 plus YNE. That gives us prop1 ine. This is also called propyne. Okay? So that's how it is identified. Many times you would not find people identifying this number 1 when they are naming a compound called propyne, because it usually is not really relevant. But then you know the steps on how to carry this out. So now that we have talked about that, let's talk about how to number the carbon chain and give the bonds priority. Now with you all through the examples we treated, you saw how I was numbering the carbon atoms, counting from left to right, counting from right to left. How did I know where to count from? That's what we want to talk about right now. When you have more than one type of bond, all right, maybe you have double bond and then you have a triple bond inside one compound, and then you have maybe a branch inside, you must follow the priority rule for numbering. It's just like, for instance, now maybe you are hungry and then you have your final exams to write at the same time, and then the final exams is in maybe 5 minutes and you are a bit hungry. You need to choose between those two options. Which one are you going to satisfy first? That is where the concept of priority comes in. In the same way, when you have more than one type of bond and you have a branch, you need to assign priority to the one that is more important, and that's what we want to talk about right now. So here are the priority rules. The first thing you need to know about priority is that double and triple bonds take priority over branches when you are numbering. So if you have a branch, like maybe a compound like this, and there is maybe a branch like this, and then there is a double bond over here, you are going to give this double bond priority over this branch. And then the second rule says choose the numbering that gives the lowest possible number to the bond. We are going to see how all of these steps will be carried out. Okay, so let's proceed into it. So the first example that shows us how to assign priority to the double bond over a substituent or over a branch is this compound that we have over here. So we have CH2 double bonded to CH, bonded to CH, which has a branch CH3, and then we have CH3 over here. Now the first thing to do is to find out the parent name or the base name. How do we do that? We number the carbon atoms. So to do that, we can start counting from the left. That will give us 1, 2, 3, 4. We can go that way, or we can still go this way. 1, 2, 3, 4. We still have 4 carbon atoms. We can even start from the right to the left. 1, 2, 3, 4. We still have carbon atoms. We can even start from the top here. 1, 2, 3, and 4. So whichever way we count it, we ended up with 4 as the longest chain. 4 gives us the parent name BUT. That will be our prefix. Now that we have taken care of the prefix, the next thing to do is to know which direction are we going to count from. Now, to know the direction that we are going to count from, we need to know what we are giving priority to. Now, what are we giving priority to? We are giving priority to the double bond over here, because it was stated that the double bond takes priority over the substituent. So now we have this CH2, CH, CH, and then CH3, and then we have another CH3 over here. So how do we know where to count from? We can start counting from here: 1, 2, 3, 4. If we count that way, this double bond is going to be on carbon number 1. If we start counting from the right to the left, however, this will have 1, 2, 3, 4. This double bond is going to be on carbon number 3. If we start counting from here, then this will be number 1, 2, 3, 4. So definitely we are going to start counting from here: 1, 2, 3, and 4. We can count that way, and we can still count this way: 1, 2, 3, and 4. Among those two ways that I just showed you, both of them are correct. So now that we have seen the direction that we are counting from: carbon number 1, carbon number 2, carbon number 3, carbon number 4. The 4 carbon atom gives us the name BUT. We have identified the parent name. The next thing to do now is to identify the branch or the substituent. Is there anything that is not part of the parent chain? Remember, this is the parent chain, and you can see there is something over here that is not part of the parent chain, and it is CH3. CH3 has the name methyl. CH3 has the name methyl, and it is a substituent in this case. And what number is it on? It is on carbon number 3. So if we want to name it, we'll say 3-methyl. Did you see how that was done? So now the next thing to do is to identify the position of the double bond. The double bond is on carbon number 1. And then the parent name is BUT. So how do we add all of this together? We start by naming the substituent 3-methyl plus the parent name, which is BUT, but, and then plus the position of the double bond, which is on carbon number 1. And then since it's an alkene, we use the suffix ene. So altogether it gives us 3-methyl but 1-ene. I'm sure you can see how that was carried out. 3-methyl but 1-ene. This but shows that it has 4 carbon atoms. This ene shows that it has a double bond on carbon number 1. And then this methyl shows that on carbon number 3 there is a methyl substituent, which is known as CH3. I'm sure you saw how that step was carried out. We gave priority to this double bond over here. Now, assuming that double bond was not here, all we had was just C, 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 and then C, and then this over here. Then we would have started counting from here, because we want to give this guy priority since there is no double bond. So we'll start counting from here: 1, 2, 3, 4. So this would have had the number 2 since there is no double bond, but in this case there is a double bond. That's why we gave priority to this guy over here. So now that we have talked about that, let's move on to the next thing that we have. There is something I want you to take note of, and that thing is that when you are naming a hydrocarbon that contains both a double bond, an alkene, and a triple bond, which is an alkyne, the double bond is given priority in the numbering of the carbon chain if both of them cannot be given the lowest number. So in a case, let's say you have a double bond and then you have a triple bond all together inside one molecule. This rule says that this double bond will be given priority. How do you give it priority? You start counting from the end that is closer to the double bond before you get to the triple bond. So let's see any example that will buttress what I have just said, and then we can call it a day. Before we do that, here are some IUPAC rules that guide that concept. The first rule says you are to number the longest carbon chain that contains both the double and the triple bonds, and then you assign the lowest possible number to the double bond, which is the alkene, if a choice must be made between the two. So let's see an example briefly. So we have this example now of a molecule on the screen, and then we can see that it contains a double bond and it also contains a triple bond. So what do we do in this case? First things first, let's know the parent name or the base name by numbering the carbon atoms. So to do that, we have carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. 5 carbon atoms tells us that the parent name will be PENT, pent. The next thing to do is to give priority to the double bond over the triple bond. How do we do that? We need to know which direction to count from. So now let's do that very quickly. So first things first, let's identify the position of the two of them. If we start counting from the left all the way to the right, this double bond that we have decided to give priority, it will have carbon number 2 because this carbon atom is the one that owns the double bond. If we start counting from the right to the left, however, this carbon atom 1, 2, 3, it will be placed on carbon number 3. So we're going to count from the left to the right. So if we do that, this will be carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. So to do that, we have 5 carbon atoms, which gives us the parent name PENT, and then the double bond is on carbon number 2. And to identify that, we have already done that, carbon number 2. The triple bond, however, is on carbon number 4. So we have done that. So now the next thing to do is to combine all of them together to give the complete name. So we have the parent name PENT plus the double bond is on carbon number 2. That gives us 2ENE, and then plus we have the triple bond which is on carbon number 4, 4YNE. So altogether what we have is pent 2 in 4 ine. That's the name of the entire compound, pent 2 in 4 ine. This 4-ine is showing that the triple bond is on carbon number 4. This 2-ine is showing that double bond is on carbon number 2. And then this pent, which is the parent name, shows that there are 5 carbon atoms. I'm sure you saw how that step was carried out and that this video is being very educative for you. So here are some quick practice questions I'd like you to try out your hands on. I have some molecules on the screen right now. I want you to name them for me and let me have their names in the comment section where I'll be willing to receive them, and I'll let you know if they are correct or if they can use some adjustments. Alright, so now that we have done that, it's time to call this video, draw the curtains on this video. Next up, we're going to be looking at how to name side groups and substituents in the 4th part of this series. Up until when I come your way next time, my name is David, and all I do here is to take the mystery out of chemistry so Chemi can make history. Till then, I'd like you to like this video, subscribe if you haven't, and turn on the notification bell icon so you'd be notified when more videos like this come out. I will see you in the next one.